The .NET Core podcast is supported by our listeners who have become patrons. To see a full list of the patrons, or to join them, head over to .NETCore.show/patrons. Hello everyone and welcome to the .NET Core podcast, the only podcast which is devoted to .NET Core, ASP.NET Core, EF Core, Signal-R, and not forgetting the .NET Core community itself. I am your host, Jamie Cabrugman-Taylor, and this is episode 10, Configuration in .NET Core. In this episode, I'll take you through just how you can configure your .NET Core and ASP.NET Core applications using the new app settings files. So let's sit back, open up a terminal, type in .NET New Podcast, and let the show begin. Cast your mind back to the days of ASP.NET development, which isn't that far back for most of us, and think of all the ways that we used to pass application settings into our web apps. Essentially, we had web.config, which was an XML formatted text file with all of our config stuff in it. Usually it started out quite small, maybe around 20 to 30 lines. Then you'd need to add a database connection string, so that added 3 lines. Then there were the HTTP headers and system.web specific config. Then you'd have some app settings like external API keys or URLs. Before you knew it, you had a massive web.config file. Then you'd have to transform it for your different environments. Usually you'd have a transform for UAT and one for live. You'd have to figure out how to tell the build pipeline to do the transform on the config for the relevant environment too. For those who don't know, a web config transform was a subset of the web config, each node having a set of attributes applied to it to tell the build system what to swap out and where. But what if you wanted to hide some of the details that were found in the web config? After all, it was just a plain text file on the server, and anyone who had access to the server also had access to the application's config. Although, if some malicious actor had access to your server, then you have slightly bigger problems than worrying about your database connection string. Reading values from the web config was fraught with danger too. You'd access it like it was a dictionary, and if your key name was wrong, you'd get a null. That's right, you'd either get a string value or a null, which meant you then had to check and then cast the value before you could use it. .NET Core seeks to make things simpler. This is where appsettings.json comes in, or appsettings.xml, or appsettings.ini if you'd prefer. If you've used ASP.NET Core, then you've already seen this in action in one of 2 ways. If you've used ASP.NET Core 2 or above, then in your program.cs file, you'll have called createDefaultBuilder. This method essentially bootstraps a lot of the code required to set up Kestrel, including loading the contents of a file called appsettings.json. However, if you've only used ASP.NET Core version 1, then you'll have spotted code in your startup class which does the same thing. Both paths eventually run the same code, which is similar to the following. If you're listening along, I'm not going to read the code out to you because you don't want to hear me reading code for the same reasons I pointed out in earlier episodes. Check the show notes for a link to the transcription and read through the code. It's pretty standard stuff. If you're using ASP.NET Core 2 or above, then you'll have to go into the declaration of the extension method createDefaultBuilder, which is found in the webhost class. Essentially what this code does is it looks in the directory where the compiled version of app is started from, i.e. the location of your app.dll or similar, and loads any files with the name appsettings.json into memory. You can think of the appsettings.json as being ASP.NET Core's web.config, with the added bonus of the file being much simpler and it being in JSON. I think we can all agree that JSON is much more human-friendly than XML. The typical things you might find in the appsettings.json for a newly created ASP.NET Core project are the logging level to use, the database connection string, calls policy names, all that kind of stuff. Appsettings Inheritance. If you take a look in the repo for an ASP.NET Core application, you'll likely find multiple appsettings.json files. Most often you'll find appsettings.json, appsettings.development.json, appsettings.production.json. All 3 of these files can be used by ASP.NET Core's configuration builder, which we saw earlier on, unless you haven't checked the show notes, that is. When we called the configuration builder's add.json file method, we passed in a variable called env.environmentName. The env variable is an instance of the iHosting environment variable, which is added via reflection for us by .NET Core and represents the hosting environment for the running application. When you run a .NET Core application, either by using the .NET Run command from the command line or one of the Visual Studios or Rider or similar, you implicitly set the hosting environment. If you don't supply it, I'll tell you how to in a moment, then .NET Core assumes that you are running in production. The reason for this makes complete sense when you think about it. How can the runtime know, at application boot time, whether your application is running on a dev machine or on a production server? So it's programmed to hedge its bets and play it safe. You can override this by prepending the call to .NET Run with ASP.NETCore_environment equals development, or by altering the launch settings.json file. This file can be found in the properties directory of your source code and contains information on how the .NET Core runtime can boot your application. The most important part of this file for our discussions is the ASP.NETCore_environment variable. Usually this will be set to development, and this is the value that the runtime will use if the file is present. If it's not, it will fall back onto a global entry, and if that's not present, then it will use production. All of this is giving hints on how application settings are handled, by the way. When your application boots, it will load the appsettings.json file as your application config. It will then look for an appsettings.environment.json file, where environment matches the environment that the application is booted in. So if you've booted in development, it will look for appsettings.development.json. If you've booted in production, it will look for appsettings.production.json, etc. If it can find that file, then it will load it and replace any key value pairs that are already in the application config with those found in the file that it has just loaded for your environment, which is a roundabout way of saying that the values in appsettings.development.json, for example, override any values from appsettings.json. I've focused on JSON files here, but you could just as easily use XML or INI files. But what about secrets? Let's say that you don't want to expose your database connection string to the outside world. In fact, that's one of the things that I pointed out in a blog post all about user secrets back in September 2017. Check the show notes for a link. .NET Core has a wonderful feature called user secrets, which is an extension of the ideas behind appsettings.json. Essentially, the idea is that you don't want to commit secrets, such as connection strings, API keys, or any kind of passwords you need in there, into source control. Ever. One of the ways that you can stop this from happening is to have those secrets loaded in from a file that is external to your binary. And I don't just mean the appsettings.json, I mean properly external. The way this works in .NET Core is to load a JSON file from the user's home directory rather than the source or binary directory. If you're on Windows, this file will be found at appdata Microsoft user secrets and ID and then secrets.json, whereas Mac OS or Linux users will find it at tilde/.microsoft/user-secrets/a user-secret ID /secrets.json. The important thing in both of those directory paths is the user secrets ID part. This is a GUID which is taken from your CS proj. An example is included in the show notes. Remember to click through to the full transcription and scroll down to where you see it. Because it's XML and contains a GUID, I'm not going to read it out because you don't want to hear me read off a bunch of hexadecimal characters and hyphens. As long as your CS proj has a user secrets ID element, then you can use the CLI to add a secret. The format of the command is .NET space user-secrets space set and then the key in quotes, then the value in quotes. So let's say you wanted to set connection string to be ./mydatabase.db. That would be .NET space user-secrets space set space connection string in quotes and then ./mydatabase.db in quotes. If you're in Visual Studio, you can right-click on the solution and choose Manage User Secrets, which will open up a JSON file for you to store your secrets in. And this JSON file will be stored in that user secrets area. If you hadn't already given your app a user secrets ID, Visual Studio will generate one for you. Just like how the values read from the appsettings.json files are overwritten by those read from the appsettings.environment.json files, any values found in user secrets will then override the values in appsettings.environment.json. But what about Azure? Let's say you've created your app, used app settings files and user secrets for all of your environments, but you want your Azure app instances to have the same functionality. Well, once you've uploaded your app to Azure, you can set secrets on the properties pane for your web application. These work in exactly the same way as user secrets, except that they are loaded in last, so will be used to overwrite the values last. Using the app settings values. This is where the extremely clever bit comes in. .NET Core will actually read your appsettings.json file into a POCO of your choice, as long as it adheres to the JSON, that is. And you can inject this POCO into any controller using standard constructor-based dependency injection. See the show notes for a short code snippet on how to do this. In this short episode, I've talked a little bit about the appsettings.json or XML or INI, how they're loaded, how you can override them with environment-specific versions, and how you can use user secrets and Azure to override them at runtime too. Hopefully you found this episode interesting, and if you have, let me know by sending me a tweet. I'm at .NETCoreblog, that's DOTNETCOREBLOG, or head over to the website, .NETCore.show, that's DOTNETCORE.SHOW, and let me know what you think. Remember to check the show notes for a link to the full transcription of this episode, which also has links to a bunch of related websites and resources. These are available, as always, at .NETCore.show. And don't forget to spread the word. Leave me a rating or a review on your podcatcher of choice, and to come back next time for some more .NET Core goodness. I'll see you again real soon. See you later, folks.